Hey guys, so this is going to be a year 11 style video for trig equations. Okay, let's jump right into it. So if we were to take an example, something simple, something like sine theta equals a half, what would we do to try to solve this? Well, if you're in year 9, you might try to sub it into a calculator using sine inverse, and that would give you something like 30 degrees as your answer. All right, but what we'll recognize is that the sine wave really looks something like this, right? And there's, sorry, a bit of the question missing here is they'd have given you a domain in which your solutions, you need to have all the possible solutions in that spot. Okay, so considering the graph that we've been given, or not given, but the one for the sine wave, we want to know when it's equal to a half. Now we know that it peaks at 1 and has a minimum of -1, so a half would be right about here, right? Now, if we take a horizontal line, we notice that there is one solution here and another solution right here, right? So what we figured out is this one. This one is the 30-degree one that we found with the calculator, but we still need to find this one. Now, yeah, so the question becomes, how do we find this? Well, if you look at the wave, just intuitively, you can see that it's symmetrical. It peaks at 1, and then it's 0. It has a height of 0 at 0 degrees, and it has a height of 0 at 180 degrees. So we know if this is 30 degrees up to here, then it's probably 30 degrees away from here. And we know that it crosses the axis. Hopefully we know that it crosses the axis at 180 degrees, and this is 360 degrees. Like every half of the sine wave is 180 degrees. So with that logic, we could kind of assume that we just go 30 degrees back, and we'll get a solution of 150 degrees. So that'd be the second answer here. Now that's a little visual and a bit of guesswork at the same time. So let's try to think of a better way. And we know we have a better way, which follows this little rule here, all stations to central. So what that means is between 0 and 90 degrees, every trig value will have a positive value between 0 to 90 degrees. So sine 30 comes out to be a half, sine 60 comes out to be √3 on 2, sine 90 comes out to be 1, but also cosine of 30 comes out to be √3 on 2, which is positive. Tan of 45 comes out to be 1, which is positive. So we get all the possible values between 0 and 90 degrees. They come out to be positive. So that's what this A represents. It represents all trig functions being positive. Now, if we move into the second quadrant, which is between 90 and 180 degrees, and if you test some values, like give me an angle between 90 and 180, well, 110. Let's just punch cos 110 into the calculator. So if we do that, we will get negative 0.34. Now that's in radians, but point is you get a negative value. Now this negative value happens because cosine is not positive. So what do these letters mean? It means this specific trig, let me circle that for you. This specific trig is the only positive thing here. So this, we'll have a guess of what S stands for. It stands for sine, right? So we know sine is the only only positive trig function between 90 and 180. Consequently, any value we put into sine will come out positive. Any value we put into cosine between 90 and 180 will come out negative, and same with tan. Now it's a little different here, where in the third quadrant, we find that tan is the only positive one. So if you were to chuck in tan 240, you get a positive value. But if you chucked in sine 240, you'd get a negative value. Okay, so knowing all that, you can rewind that to try and decode what I said if you found it a little confusing. But in summary, all trig is positive in the first quadrant, only sine is positive in the second, only tan is positive in the third, and only cosine is positive in the fourth. So knowing that we're dealing with a sine function, we're looking for a positive value. It means we're looking for solutions in the first and second quadrant. Now we already have our solution for the first quadrant. That's the 30 degrees, and I hope you can see that. It's between 0 and 90. So that's the first quadrant covered. We just need to figure out where the second one is. So the second one is just the equivalent of the first one. That's how I like to think of it. The equivalent of the first one, but it's just in the second quadrant. So we take our 30 degrees that we found, and we do 180 minus. Now you're wondering, and that gets you 150. So now you might be wondering why we do 180 minus, and that's just because of the fact that we're looking for, let's switch colors again. Let's go for green. That's just because we're looking actually for this angle here, right? We want that angle, not the little angle here. That's just because of a convention. We always take angles from the positive x-axis, right? Positive x-axis. So we'd be going from here all the way over to here, which is 150 degrees, right? And so this might seem a little more complicated, but with practice, it'll be simple. That's the better way of approaching these sort of questions. It's good to have these graphs in mind, but it's a little slower if you have to graph it up every time, or it takes up space and all that. So you can hold these in your head quite quickly if you know all stations are central. You're like, oh, sine, I'm in the first and second quadrant. The base angle is 30 degrees. So the second quadrant will be 180 minus 30 degrees, and I'll get 150 as my solution. Okay, so let's try a slightly different one. Let's just see what happens when we make it a negative value. So let's try -1 on root 2. So with this, once again, I'd punch it into the calculator. And as usual, similar to the previous question, I try to find a base angle. So in this, I'm gonna denote that with a little beta here. My base angle is actually going to be 45 degrees. You can do that by punching in cos inverse 1 on root 2, careful there, cos inverse 1 on root 2, not negative, and you'll get 45 degrees. But of course, that's not what we're looking for, right? We're not looking for 1 on root 2. We're looking for -1 on root 2. So where is cosine negative? In what quadrants is cosine negative? And we go back to this and we're like, it's positive here, it's positive here. So it's negative in the second and third quadrant. Okay, it's positive in the second and third quadrant. And since we know the base angle is 45 degrees now, all we have to do is go 45 into the second quadrant. So 180 minus 45, which will give us 135. And we go into the third quadrant by adding 45 to 180. So we'll get 225. And now you can check those by punching in. This will be a little harder to check than the previous one. But you can sub cosine 135 into your calculator, and it should give you 1 on root 2. It's actually going to give you a decimal, but if you were also to type in -1 on root 2, you get the same decimal, and you'll see that they're equal to each other. Okay, so what you might have been able to notice, I'm going to get rid of this while I talk. What you might have noticed is we seem to get two solutions within this 0 to 360 domain. Okay, now this isn't always true. So let's take another question. Question 3, something like really easy, sine theta equals 1 and the same domain. Oops, that's a 0. So sine theta equals 1. We punch that into a calculator. This one's quite simple. And you get 90 degrees. If you sine inverse 1, and you can see that from the wave here, if you go 90 degrees, which is here, you get a value of 1. Why doesn't this have two solutions? Well, let's take a look. Let's use the same method. So we want to know where we have positive values because we're looking for a positive 1. Where does sine have positive values? The first and second quadrant. Now, if I was to just take the base angle, which was previously an acute angle, like 30 degrees or 45 degrees, if I was to take that base angle and use it for this scenario, that idea for this scenario, I'd have a base angle of 90 degrees, which would mean that this is my base angle here, this little value here, right? This would be my base angle and my first solution. Okay, fine, that's cool. Now we've dealt with our first quadrant. What about our second quadrant? Because that's what we always do. So we go second quadrant. And we're like, okay, I know sine's positive here, so I'm going to do, as usual, 180 minus the base angle. But what is the base angle? It's 90 degrees. What happens when I do 180 minus 90? I get back to 90 degrees. So it's kind of a redundant solution. And therefore, there's only one solution to this specific one between 0 to 360. That's also easier to see graphically because there's only one point at which the sine wave reaches a value of 1, which happens to be at 90 degrees. Okay, so some values, just be wary, some values will have less than 2 solutions. Some values have more than 2 solutions. Have a think. What value could give us more than 2 solutions? Let's stick with our sine wave. Let's imagine I set it equal to 0. So if I punch this into a calculator, I'll get theta equals 0 degrees. But then we have to consider, again, where is sine positive? First and second, base angle is 0. Okay, so I get 0 degrees as a solution. I also get, in the second quadrant, 180 minus 0, which is 180 degrees. So you'd think, hey, there's 2 solutions here. But if you look very carefully at a sine wave, you'll notice that it's 0 here, it's 0 here, but it's also 0 here. So in this case, you get 3 solutions. So while it's generally true that you'll have 2 solutions to anything that to any sort of trig equation, you'll generally have 2. It's not always the case, and you've got to be wary. So knowing the graphs is definitely helpful, but you don't want to do them every single time because that'll slow you down in a test scenario. It's better to do all stations 2 central. Okay, let's do one last one. This one's going to be a little different. We're going to, I think what we'll do is let me just rub that out too. Why not while I'm here? Okay, what we'll do is we'll just make it slightly more algebraic, not really too much harder. What are we up to? Question 5, I think. Let's do something that isn't an exact value. Something like 4 sine theta minus 3 equals 0. So this looks a little different. It's not too much more work to do, it just looks a little different. Here's a good thing to keep in mind. Since we know how to approach things now, that when they are sine theta equals something, that would be a good form for us to change this equation into. So let's try to do that. Let's try to make sine theta the subject of the equation. So how would I do that? So considering this just an x, I would move the 3 over. So I get 4 sine theta equals 3. And I move that 3 by adding 3 to both sides, and then dividing by 4. That'll give us 3 on 4. Okay, so now solving this into a calculator, and this is not an exact value, so I'm going to have to get my calculator out. So that'll give us 48 point, I'm going to round that to 6, 48.6 degrees. Okay, but as we know, in this domain, there is generally 2 solutions. Where is sine positive? First and second quadrant. This is our first quadrant solution. So our second quadrant solution will be 180 minus that, which will come out to be 131.41 degrees. Okay, cool. So hopefully that helped with trig equations a little bit.